In this video, we will be looking at examples from 8.4 of your XYZ homework. This will be one like number 1. Here we see 4 over 5 divided by 3 over 4. Well, I can rewrite this division like this. 4 divide 5 divided by 3 divided by 4. A fraction is just a division problem. We call this a complex fraction. It's a fraction in the numerator and a fraction in the denominator. So 4/5 divided by 3 over 4 is the same as 4/5 divided by 3 over 4. This is just restating this problem. Well, when we divide by a fraction, we multiply by the reciprocal. So I'll leave the first fraction the same, 4 over 5. I change my division to a multiplication. Division becomes a multiply. And then I will find the reciprocal, that is, flip over the second fraction, 4 over 3. Now, when multiplying fractions, I just multiply numerators times numerators and denominators times denominators. 4 times 4 is 16, and 5 times 3 is 15. This is 16 over 15, or 1 and 1/15. 15 goes into 16 one time with 1 remaining. All right. Complex fraction where both the numerator and the denominator are fractions themselves with a subtraction. So we're going to have to find a couple of common denominators here. Looking only at the two fractions in our numerator, we have 3 over x minus 2 over y. We need to find a common denominator here. Well, this one has an x, this one has a y, thus my common denominator is an xy. In order for this fraction to be over xy, I will multiply by y in the denominator and the numerator. Now this fraction, we need to pick up the x factor. Thus, I will multiply by x in my denominator and in my numerator. And by convention, we put the x behind the coefficient. Alright, so I multiplied by y over y in the first fraction, x over x in the second one. Now I'm ready to subtract. I see my common denominator is an xy. 3y minus 2x is 3y minus 2x. By convention, we typically write the x term first, so I'll say negative 2x plus 3y. Notice it's negative 2x and a positive 3y. Alright, now into my denominator. Again, we have an x and a y, thus my common denominator would be xy. This first fraction, I will multiply by a y in the numerator and the denominator. The second fraction, I'll multiply by an x in the numerator and denominator. Alright, so once more, my denominator is xy, and my numerator is 5y minus 4x, or stated with the x first, negative 4x plus 5y. Alright, so I have this fraction divided by this fraction. I will rewrite that. Negative 2x plus 3y over xy divide by this fraction. Negative 4x plus 5y equals, over xy. Well, when we divide by a fraction, it's the same as multiplying by the reciprocal. So, negative 2x plus 3y over xy. We leave the first fraction the same, times the reciprocal of the second one, flipping it over, xy over negative 4x plus 5y. Okay, well, we can see that these two will cancel each other. They divide to leave 1. Negative 2x plus 3y times 1 is just that, negative 2x plus 3y. And then 1 times this polynomial is simply negative 4x plus 5y. Alright. Caution, do not attempt to divide negative 2, to cancel negative 2 and negative 2 here. They'll be left with a 1 over 2. this term is added to this term. We cannot do cancellation when we have things added. We need to have them strictly multiplied. So this is as simple as we can write this expression. All right, we have 1 minus the fraction 4 over a plus 5 divided by 1 minus 1 over a minus 5. Well, again, we have this binomial in the numerator and the denominator. So we're going to first simplify each one of the numerator and the denominator. 1 I'm going to rewrite as a fraction with a plus 5 as the denominator. So 1 I can write as 1 I can express as the fraction a plus 5 1 I can express as the fraction a plus 5 divide a plus 5. I express it over a plus 5 because that's the common denominator, and anything divided by itself is 1. Likewise, I'll express this 1 as a fraction a minus 5 over a minus 5. Now we're ready to simplify the numerator and the denominator. We have the common denominator a plus 5. I have a plus 5 minus 4. Well, 5 minus 4 is 1. This becomes a plus 1. Here's my divide bar. The bottom, we have the fraction a, or the expression a minus 5 as my denominator. In the numerator, we have a minus 5 minus 1. That becomes a minus 6. Okay, now I'll re-express this statement as a plus 1 over a plus 5 divided by this fraction, a minus 6 over a minus 5. Now I can invert my second fraction. If you want to, when you're doing this, if you want to skip this middle statement, that's fine. I'm showing it so that you're clear about what's going on. Leave the first fraction the same, a plus 1 over a plus 5. Changing my divide to a multiply and inverting my second fraction, a minus 5 over a minus 6. Now I can multiply these together. One way I could simply do is just connect these parentheses, a plus 1 times a minus 5 over a plus 5 over a minus 6. Well, now I can, this could be a answer here, but I'm going to distribute these. A times a is a squared. A times minus 5 is a minus 5a. 1 times a is a positive 1a. Minus 5 and plus 1 is a minus 4a. 1 times minus 5 is a minus 5. A times a is a squared. 5a and negative 6a yield a negative 1a. And 5 times minus 6 is a minus 30. Alright, either one of these are acceptable answers. Alright, last problem for this video. In this case, we have a fractional numerator that is a trinomial, divided trinomial, and the same for the denominator. So I'm going to rewrite this. Again, my first fraction, t squared plus 2t minus 3 over t squared plus 4t minus 5. And I'm going to go ahead and change my division to a multiplication and invert my second fraction. I'm skipping that middle statement. T squared plus 2t minus 3 over this one, t squared minus 2t minus 15. So it was my top fraction. Instead of writing my divide, the bottom one, I went ahead and changed my division to a multiplication, and I inverted my second one. This denominator is now my numerator. This numerator is now the denominator. Alright, well this one is just going to be a big factoring problem. We're dealing with trinomials, so I can use my big X method. Using my big X method on this one down here, I know t squared will be t times t. Okay, so coming with my big X, and the top is b, and the bottom is a times c. b is negative 2. a times c is 1 times minus 15. Since this is a subtraction, I know one will be a plus, one will be a minus, because I need two things to multiply to be negative 15. Well, what multiplies to give 15 but subtracts to give 2? Well, that's going to be 5 and 3. Negative 5 times positive 3 is a negative 15, but negative 5 plus 3 is a negative 2. These two will go here. Plus 3 and minus 5. Okay, I'm going to go directly to the factored part. I will leave the big X method to you in this case. T squared is t times t. If this is a minus, one's a plus and one's a minus. 3 is going to be 3 times 1, but we need a positive 2 in the middle. It'll be a plus 3 and minus 1. One thing here, look for clues in the bottom. We know we're going to have some canceling, so this t plus 3 and that t plus 3, they're going to cancel each other. Looking at this one, t squared is t times t. A minus, 1 plus, and 1 minus. 5 is going to be 5 times 1, but we need a positive 4, so it'll be a positive 5 and a minus 1. This one, t squared is t times t. A minus, 1 plus, and 1's a minus. 3 is 3 times 1, but we need this positive 2, so it's a positive 3 and a minus 1. T times t is t squared. 3t and negative 1t is a positive 2t. 3 times minus 1 is minus 3. Alright, now any numerator can cancel with any denominator. You see that t minus 1 will cancel with t minus 1. T plus 3 can cancel with t plus 3. And that will be all. So my final answer in this case, my numerator is t plus 3, t minus 1. And my denominator, t plus 5, t minus 5. And I could multiply these out, but I will leave it in this form. T plus 5, t minus 5. And this is a good answer in this context. Alright, that should help you with 8.4.